Hi, my name is Jay.
I'm Sam.
I'm Eric.
Our project was to create a simple walkie-talkie using the 802.15.4 protocol. 802.15.4 is a wireless IoT protocol we learned about in WES207.
This project was built from the ground. Many pieces we selected.
We had two main motivations in our project. The first was to create something that utilized all of the knowledge that we had gained from all of our WES classes. Our other main motivation was to create something with components that could be reused in other WES projects or by other people through our open source GitHub repository.
To begin with, we'll go over in details how this project works.
As mentioned earlier, our project is a walkie-talkie that is able to send and receive audio data. We'll start by going over the components we chose and then summarize it with an explanation of how the data flows through the system end to end. This is a Teensy 4.1. It's a microcontroller that serves as the brains of the operation and has many different interfaces for communicating with other components. It also has an SD card reader that allows us to save and store audio data.
This is RLB215 Explorer A board. This RF transceiver board has RF front-end, mixed signal parts integrated together with a processor that can take packets provided by the Teensy board and transmit them using an OQPSK waveform that is compliant with 802.15.4 standard.
This is the PDM board, which features an onsemi fan 3852 analog to digital converter.
This is a MAX 98357i2S audio amplifier module. It converts audio sent from the Teensy to a waveform that can be played by the speaker.
Finally, we have the FNX T20 BGA256 FPGA board. This is an optional part that could be used to communicate with the Teensy as well as with the RF transceiver. It can be used if high data rate processing is required. This board will not be used for any of the demos shown in this video.
To summarize, we'll go over the signal flow through each of these components. First, audio is recorded from the microphone through the analog to digital converter and sent to the Teensy through a PDM interface. Alternatively, an audio file can be loaded from an SD card and transmitted instead. The Teensy board then compresses the audio data using Skype's Opus codec and separates the compressed data into 802.15.4 packets. The packets are then sent from the Teensy to the transceiver through an SPI interface. The transceiver board transmits the packet to the other transceiver using OQPSK modulation. The transceiver on the other end then relays the received packet to the Teensy board back over SPI. The Teensy extracts the audio data, decodes it, and then sends it to the digital to analog converter over I2S. The DAC then sends the audio out through the speaker.
Okay, so to start our demonstration, I'm going to use this setup as the receiver, and I'm going to set it into RX mode through the serial interface. So I'll send the RX command, and then it indicates that RX has been set. So going over to Eric.
Yeah, then I'm gonna send OK voice with this command, OK command. Then, are you ready?
Yeah.
I'm gonna send OK. Then simple OK voice is transferring to the RX side.
And as we can see, we are receiving packets on the receive side, and it is not indicating there are any errors so far. And once it's complete, it will play back the message that Eric sent.
Okay.
And now for our audio recording demo.
Hello. Hello.
Did you press enter?
Yes, it's transmitting.
Okay. Alright, we are receiving over here. When it's complete, we should hear our recorded audio.
Hello. Hello.
Wow.
So that concludes our demonstration.
We really appreciate our professors and everybody else helped this project.
All of our source code and instructions are available on our GitHub repository, so please check it out if you're interested.
That's it for our project. Thank you for watching.
Thank you.